So let's take a look at an example of a linear function in context. So we're going to start by looking at a cost function. So we'll call this C of Q, which means that the cost C depends on Q, the quantity of items that are produced. So the formula that we have here is that C of Q is equal to 4.5Q plus 750. Now, if you look very carefully at this equation, it looks a lot like y on the left. So y is the same thing as C of Q. And on the right, instead of m times x plus b, we have 4.5 times q plus 750. So the two components that are on the right represent the slope and the y-intercept. The first component, the 4.5, represents the slope of this line, the slope of the cost function. And in this context, the slope tells us that the costs of production are increasing at a rate of $4.50 per item produced. Now, whenever we talk about a slope or a rate of change, we're always going to need to include units that look like this. In this case, it's dollars per items produced. So the dollars comes from the vertical axis, and the items produced comes from the horizontal axis. This particular component of the cost equation contributes to what we call the variable costs. Because the quantity that we produce might vary, that's going to change the total cost of production, and so we call this particular piece of the function the variable costs. When you look over at the 750, that's your y-intercept, and in this particular context, this is what we would call the fixed costs. So we have $750 in fixed costs, and that represents the amount of money that we would need to put out or invest before we would actually produce any items. So this could be what we would call startup costs. So let's take a look at what this would look like in visual form. So here's a picture of the cost function in graphical form. So you can see that this line is going up, and from the slope of the line we know that it's going up at a rate of 4.5 units in the y, or the vertical direction, for every 1 unit in the horizontal direction. You can also see that the y-intercept is at 750. So if you look at the vertical axis here, you'll notice that that is intercepting the y-axis at the value 750. So this is a picture, and on the next slide there's a video that you can take a look at and how I produce this. But for now we want to answer this question at the top of the slide. What is the total cost to produce 50 units? So notice that the 50 units being given to us is a value of Q. It's not a value of cost. So that 50 is going to go and be substituted into wherever we see a Q. So we call this evaluating a function. We're letting Q equal 50. And so we evaluate this function at 50. So on the left side here, we say C of 50, the cost at 50 units, is equal to 4.5 multiplied by the value of Q, which of course is 50, plus 750. So this is the value of the cost function at 50 units produced. And then the right side of the equation is simply computed using basic arithmetic. We multiply the 4.5 by the 50 to get 225. We add 750, we get 975. So we want to make sure that we can interpret that 975 correctly. Remember, this is equal to C of 50, the cost of producing 50 units. And so what we would say then is that to produce 50 items, it will cost $975. Now, you can actually see this on the graph. If we go to the horizontal axis, the Q axis here, we can locate where Q is equal to 50, and then we go from the horizontal axis up to the line, we place a dot there, and then when we go directly over to the vertical axis, which is the cost axis, we see that that value is just below 1,000, and the actual numerical value is 975.